Hello everyone, welcome to this next video on the outlier detection. So we'll use two methods to detect the outliers. We're not going to do any visualization at the moment. We'll get back to that in our next chapter. So very first thing, I'm going to just demonstrate how we kind of detect outlier based on known values. So what I'm trying to say here when I say known values, so we created a new data frame so that we can keep an original data frame intact. So we did a descriptive stats, describe the data frame. So by looking at descriptive stats, let's say we are only selling detached homes, uh, single family homes, bungalows. So we know that we can't have 10 full baths, right, in those type of houses. We can't have 40 rooms as well. We can't have 10 floors. We cannot have a total value as a negative number, right? So just by kind of doing some visual inspection of descriptive statistics, we know that we need to remove those entries, right? So for that, what we can do, we can create an array to keep track of those indices where we have outliers in this data set. So I'm going to call it outlier index. And we're working with housing data frame number 4. So we can use a conditional selection, which means in housing data frame number 4, return me all the values based on the total value column where the house price is less than $100,000. Let's use another condition, or you can use and as well. It depends on the which you want to determine. So housing data frame number 4, return me all the values where the full baths are, let's say, greater than 4. Right? So this will return all the rows in this particular data set, and we only want to get the index. So we'll use index here to get those values. So let's print out the outlier index to see what we have here. So we have 3 indices, like transaction number 86, 1,468, 5,802, where we have these outliers. So in order to drop or remove the outliers, we can use a drop function. So in this particular case, we will have housing data frame number 4 drop, and we already have our indices stored in the outlier index, and we'll set a value in place equals to true. So in place true simply is telling the compiler to overwrite the data frame number 4 that we're working with. Data describe, sorry, data frame number 4, right? 4. So if you scroll down now, I mean, you can see the negative value from this particular total value is gone. Now we have full bath 4 maximum value. So we kind of managed to drop those outliers from a data set, right? So similarly, you can try dropping the outliers based on number of floors, based on number of rooms. So please do a little bit of practice on that. The second method we're going to use by using normalization. So for normalization, we will use the standard deviation in order to get the normalized data set, right? So in this particular case, I'm going to create a new data frame again. So housing data frame number 5 equals to housing data frame copy, right? So we copy the data frame, and from here we want to calculate the mean value and divide by the standard deviation, right? So as we calculate standard deviation and mean, in this particular case for housing data frame number 5, so let me just explain this first. So we have a attribute which is remodel. It has values which are categorical values, right? So we cannot apply mean or standard deviation function on the categorical values. So the point I'm trying to make here is when you have strings, categories stored in a data frame, we want to drop those columns first, right? So in this particular case, we will drop the housing data frame number 5, the column, sorry, we're going to use drop, and in this case, we want to drop the remodel column from our data set, and in place will be true. So again, in place will kind of overwrite the data frame, and axis equals to 1. So axis equals to 1 means we are working column wise. So 0 means axis equal to 0 means row, axis equals to 1 means column. So let's print out the housing data frame number 5 again. So let's do that. Right. Sorry, in place, PL. Let's do that. So as you kind of scroll to right, you will see the remodel is dropped now. So once the remodel is dropped, now we can do the normalization, right? So in this particular case, I'm going to create a new data frame called z-score, and we're working with housing data frame 5. So we'll subtract housing data frame 5 mean from each value, and we want to divide this by the standard deviation. So housing data frame 5 dot, I think it's STD for standard deviation, STD, and let's print out the z-score. Okay, right, what did we do here? Yeah, so that's just warning, right? So the only columns, uh, we can say numeric only equals to true, numeric only equals to true, right? Okay, right, so here we go. Because if you remember, we have some missing values within this particular data set, right? In housing data frame number 5, right? So you can set that to true. So when we use z-score, we want to make sure everything falls within plus minus 3 standard deviation. So from minus 3 standard deviation to plus 3 standard deviation, right? So anything outside plus minus 3 standard deviation, we will remove it, right? So again, the other thing you can do is you can do z-score describe. So we know that in this particular case, we have a maximum value of 8.27, right? A minimum value of 8.42. So we want to drop anything based on the total value column, which is outside plus minus 3 standard deviation, right? So the rest of the process remains same. So let's create an index. So I'm going to create a new variable, outlier index 1. And we are working now with these z-score, this particular uh, data frame. And what we want to do is where z-score total value is less than minus 3, or remember plus minus 3 standard deviation, either less than minus 3 or greater than plus 3, right? Sorry, we don't need to put plus here, greater than 3 index. Let's print out the outlier index 1. So we have, sorry, we use the wrong condition. It should be greater than 3, either less than 3 or greater than 3. Okay, so we have few indices where based upon the normalization by using z-score, we found that there are outliers. So using z-score method is much more efficient, much better than simply looking into outliers visually, right? So in this particular case, when we kind of looked into the outliers based on certain values, so you need to have a very good knowledge about the data set. You need to have a good domain knowledge, right? Otherwise, you may not be able to capture all the outliers, right? So in this particular case, again, we retrieved all the outlier indices. So now we can go ahead and work with housing data frame number 5, drop, and we want to drop the outlier index that we determined, right, in place equals to true. And let's print out housing data frame, housing data frame 5. So we have only 5,718 rows, right? If you look into the original data that we copied earlier, housing data frame, we have total 5,802 rows, right? So we end up removing outliers based on the total value column, right? Okay. So please do a bit of practice, try to work around with some of the other columns. For example, floors, rooms, you have outliers in those columns as well. And if you have any questions, please let me know. So I'll pause, kind of complete this video here, and kind of see you in the next video. We'll kind of wrap it up with the remaining components. Thank you.